Hey everybody, welcome to Chem. We're going to do a combined gas law practice problem, and volume is held constant in this one. It says the gas left in a used aerosol can is at a pressure of 1.30 atmospheres at 27 degrees Celsius. If the can is thrown into a fire, what will the pressure of the gas be in atmospheres when its temperature reaches 927 degrees Celsius? Assume that the volume and amount of gas are both held constant. Show all of your work. Don't forget, you can only use Kelvin for temperature when doing calculations. We got some Celsius thrown at us here. So let's turn that into Kelvin. The way to do that is Kelvin equals degrees Celsius plus 273. So 27 degrees Celsius and 927 degrees Celsius, we can't use them. So if you change them to Kelvin, 27 degrees Celsius becomes 300 Kelvin. And then 927 degrees Celsius becomes 1200 Kelvin. I always like to write out my variables so that I know what I have. So we've got P1, T1, P2, and T2. The reason why I didn't write volume here is because it says assume that the volume and amount of gas are both held constant. If something is held constant, you're not going to use it in your calculation. So my first pressure is 1.30 atmospheres. My first temperature is 300 Kelvin. My second pressure is what I'm trying to find. And my second temperature is 1200 Kelvin. Okay. And here's my formula. I've got P1 over T1 equals P2 over T2. Now, normally, remember, there's volume in here, but because they said it's held constant, I'm not taking it into account when I'm calculating. So I'm not even going to write it just so that I don't confuse myself. So now I just have to sub in what I have. So 1.30 atmospheres goes up here over 300 Kelvin, and that is equal to my P2 over 1200 Kelvin. Now, at this point, you probably know some fancy math tricks, multiplying by the reciprocal and all sorts of things like that. I always tell my students to work smarter, not harder, which means let's just cross multiply. You always, usually I should say, get the right answer as long as you plug it into your calculator the right way. So I'm going to multiply the yellow numbers together and then multiply the pink numbers together. I'm going to put my yellow numbers on the left side of the equal sign and my pink numbers on the right side of the equal sign. So 300 Kelvin times P2 is going to get me P2 times 300 Kelvin. And then 1.30 times 1200 is going to get me 1560. I'm going to bring my units with ATM and Kelvin. My overall goal is to get P2 by itself, and in order to do that, I have to divide each side by 300 Kelvin. When you divide something by itself, it cancels. And same goes for the Kelvin units over here. And I need to pull down my P2. And then 1560 divided by 300 is going to get me 5.2 ATM.